Banger. This is Mr. Bondy, your favorite tutor, and we are taking implicit differentiation today. Yes. Um, we have been doing explicit. What's the meaning of explicit? Explicit is of this form: y equals to f of x, that is y stands alone, and we have a function of x at the other side. This is called explicit function. But when we say implicit, that means both x and y are involved. So that we have something like f of x comma y, meaning a function of both x and y will be there in the equation. This is what we call implicit. Can you see the difference now? See the difference. It can also come in this form: f of x dot f of y, something like this, equal to 0, or equals to, let's say, 1, because it's multiplication. Are we here now? So this is implicit too. So any function involving both x and y is implicit. Now, also, how do we differentiate x? You know that if you want to differentiate y is a function of x. So if I want to differentiate this one with respect to it, I will say it is what? Dy dx, which means what? The dx of what? A function of x, which will give me what? F prime of x. Can you see that? But if I'm differentiating a function of y, let's say I'm differentiating a function of y with respect to x, then it is still what? F prime of x, but you need to multiply with what? Dy dx. This is introduction. So that's what makes implicit differentiation different from what? Explicit differentiation. Because explicit, we are only concerned with a function of x, while implicit is concerned about function of x and what? Function of y. Are we here now? Example of implicit, we have something like, let's say, an example is when we have something like x squared plus y squared equals to what? 1. This is implicit because there is a function of both x and y. Another one is when you have x squared y cube plus sine xy plus exponential xy equals to what? 5. This is another example of what? Implicit equation. And if you want to differentiate, let us move to the next uh, portion. So we have this question. What's the question? You have to find dy dx and discover dx squared of these two. Now, question one, quickly. So question one is saying x squared plus y squared, and we know that this is what? Implicit. Now you just differentiate through with respect to what? X. That means differentiating each of the time. Oh yeah, differentiate x square, we have what? 2x, abi? With respect to x. Then differentiate y square to now be 2y. Remember, you now add what? You now multiply with what? Dy dx. Every function of y, if you differentiate, you have to put what? Dy dx. Are we here now? Because oh yeah, differentiate one, that's 0. So you now make dy dx subject of the formula. So you send non-dy dx to the other side. So it becomes 2y dy dx equals to what? Minus 2x. So my dy dx equals to what? Minus 2x all over what? All over 2. All over 2y. So 2 cancels 2. So we have minus x all over y. That's the answer. Can you see? Now, discover dx squared. That means you are differentiating this again. Meaning you are differentiating dy dx. That is, you get d square y dx squared from what? That's second derivative from what? Differentiating the first derivative. Are we here now? That's why we are going after implicit. I will quickly brief you on higher derivatives. So differentiate this first derivative, you have second derivative. That will be what? That will be differentiation of this guy. And if you are differentiating this, that means you are using what? Quotient rule, because it is a division. So that means that will be v vu prime minus what? Uv prime all over v square. That's what I'm using. So quickly, you can quickly do this even sef without writing v and u. Oya, what is v? V is what? Y. Abi, what is u prime? U prime is, u is, you know this u, this is what? V. U is what? Minus x. So differentiate minus x, you have what? Minus 1. Abi, then minus, oya, u. What is my u? My u is what? Minus x. Abi, differentiate v, that is what? You are differentiating v with respect to x. Like I said, this is a function of y. Oya, differentiate y, that will be what? 1. Oya, multiply with what? Dy dx. Can you see? So all over, can you see? All over what? V square. What's v squared? That's y, then squared. Oya, multiply 2, what do we have? We have minus y plus x dy dx all over what? All over y squared. Are we here now? So what is dy dx? Can you see it here? You now bring it here straight away. So this will become minus y plus x into what? Minus x over y, because dy dx is minus over y. Then all over what? Y squared. This is how to solve questions like this. Are we here now? So quickly, let me clean the first one. You can let me clean the first two lines so I can complete the solution. Now, so what do you have here? I'll just multiply to, I have what? Minus y. I have minus y like this, then minus what? X squared all over y, right? All over what? Y squared. You can just take the LCM of the what? Of the numerator. This will be y. So this will be over 1. 1 in y, that's y. Y times this one, it becomes minus y squared, and y cancels y, then minus what? X squared, then all over what? Y squared. So if you divide this, what do you have? We have minus y squared minus x squared all over y cube, because I know that this will be the same thing as times 1 over y squared. Alright, so quickly I can just factorize the answer. This minus into what? X squared plus y squared all over what? Y cube. That's the answer. Can you see that? So I've gotten it like that. See the second example here under implicit differentiation. All you need to do is, it's a product rule here. Can you see that? It's a product rule here because you have a function of x multiplied a function of y. Now I will need product rule here. What's product rule? You just picture it in your mind. You know that product rule is what? U dv dx plus what? V du dx. Are we here now? Yeah, now what is u? U is x cube. Write it out. X cube. Open the bracket so it won't mix with the others. X cube. Oh yeah, what is dv dx? Dv dx is what? 3y square. What did I tell you about a function of y? Anywhere you see it, even if it is a method inside another method, you have to multiply by dy dx whenever you are differentiating a function of y. So 3y squared, then dy dx. Can you see? Then plus product to v. What is v? V is what? Y cube. What is du dx? Du dx is it? That's 3x squared. This is just the simple differentiation of this guy. Now coming to the next term here. If you differentiate exponential, you have what? Exponential x plus differentiate sin y. What do you have? We have cos y, a function of y. That's what? Dy dx. Then plus 3. I think this is a product rule too. Xy product rule. The same way here. Oh yeah, pick u. U is what? X. Differentiate for y. That's what? 1. Then dy dx. Are we here now? Plus, oh yeah, pick y. Oya differentiate x, we have what? 1. Close your bracket, then equals to what? 0. So all you need to do is just simplify this everything. Oya, this is what? 3x cube y what? Y squared, am I right? Dy dx plus what? 3x squared y cube, then plus exponential x plus cos y dy dx, then plus what? 3x dy dx, this one, then plus 3y equal to what? 0. Let me teach you how to just factorize dy dx here. It's very simple. I will I will I will write dy dx first, still, then equals. Now send in your mind, send all non-divided dx to the other side of this. So that means they will take minus. That will be minus 3x squared y cube. This one too, minus exponential x. Then which one again? Minus what? 3y. Then oya say over. It's always like this. Then over, oya divide by the what? Coefficient of dy dx. That will be starting with what? 3x cube y squared. The second one plus cos y. The third one is now what? Plus what? Plus 3x. Can you see? Plus 3x. That's the answer. Shikena. That's a shortcut. It will cut out like two steps. You are doing CBT. So learn how to cut your long story short. I hope you enjoyed this video. Please share to your friends. I still remember Mr. Bonde of Bonde Tutorial.